Hey there, Spiceheads. Thanks for hanging out with us today for the webinar, Powering Your Dream Server Room, Part 1, Blade Servers, Hyperconverged, and Converged Infrastructures, brought to you by Cisco and Eaton. Before we get started, I do want to remind everyone this webinar is being recorded, so if you have to step away, you will get an email with a link to the video in just a few days. Also, there's a Q&A box on your screen to the left, and I encourage you to submit your questions throughout the presentation. If we're not able to get to your question live, someone will be able to follow up with you. As usual, we also have a live chat, so join in by clicking the blue widget at the bottom of your screen. Now let's get started. Today's presenters are Tony Harvey. Tony has been with Cisco for 7 years. He is a Cisco Senior Product Marketing Manager, and as a wild man, he used to rebuild and ride motorcycles. Tony, would you like to say hello to our audience?
Hi, audience. Hi, Spiceheads.
Awesome. We also have Randy Maples, Eaton Software Technical Marketing Manager. Randy has been with Eaton since 2008 after graduating from Appalachian State University with a Bachelor's of Science in Physics. In his spare time, Randy likes to hike the mountains of western North Carolina with his wife and daughter. Randy, would you like to say hello to our audience?
Greetings, Spiceheads.
Perfect. All right, guys, so let's get started by chatting about hyperconverged and converged. Many of our companies and IT pros are looking to update their server rooms, their compute and storage infrastructures. How should they go, or should they go with converged or hyperconverged?
That's a really good question. And the answer is, of course, it depends. That's always the answer to everything in compute. It always depends. So before we sort of look at whether you want to go converged or hyperconverged, really let's just look at a few definitions to make things a little bit easier so that we're all talking about the same stuff. So define converged infrastructure. Converged infrastructure is a pre-tested, pre-configured, bundled solution which consists of compute, network storage, and the management software. And there's lots of converged infrastructures out there. Now, obviously, you're going to get the Cisco side of the view of the world on this presentation, but there are other vendors out there as well. But Cisco's a part of FlexPod, for example. That's one of the bigger converged infrastructures out there that goes along with our friends at NetApp. We're part of vBlocks from VCE, and even within converged infrastructures, there's subtle differences between the types of converged infrastructures. FlexPods, for example, are based around what we call a Cisco validated design, which is a white paper that, well, it's actually more than a white paper. It's a 100-page document that details everything about the configuration, how we set the BIOS up, how you set all the OS parameters up, how you set the storage parameters up, how you cable it all up, how you connect it all together so that you can build out of your own components something that is either exactly the same as that CVD, but it also gives the option to take a riff off of that and do something slightly different because your environment might not require exactly what that CVD is targeted at, but you can use it as a basis to work something different. So you have these things like FlexPods, very, very flexible. And then you have VCE, vBlocks. vBlocks very rigidly architected. When you're talking about a vBlock, you're going to VCE and asking them, I want to do 1,200 VDI desktops. And they'll sell you a block that does 1,200 VDI desktops and it'll give you SLA's guaranteed level of performance. But you can't change anything inside it. You can't tweak it. You can't adjust it. So you get both ends of this. And then again with EMC, we have vSpecs, which is a more flexible version, sort of similar to FlexPods. We have IBM Versa specs. If you're into IBM storage, we have UCP Select with Hitachi. We have SmartStack with Nimble, which plays in a little bit at the lower end compared to some of the FlexPods, although they can extend up now. As they've gone all flash, they have an all flash array, and the newest one that's just come on board really has been Pure Storage, where we now have flash stacks along with those. So a whole bunch of vendors, and it's really that combination of compute, network, storage, the management software, and typically within the CVDs, and especially with vBlock, that would also include the hypervisor or the operating system that you're going to be running on top of the actual server hardware itself. So that's converged. What about hyperconverged? Well, hyperconverged infrastructure is a kind of converged infrastructure that uses what we would, in Cisco terms, is software-defined storage, where you take a traditional rack mount server and you take the storage inside that rack mount server, you layer some software on top of that that allows you to combine multiples of those rack mount servers and present the storage up to a hypervisor. And that storage is seen as a single block of storage, but a single storage array that's spread across multiple servers, and the VMs have access to all of that storage on any one of those connected devices. And you're running the VMs, the storage services, and everything on those rack mount servers. Now, the one thing that's missing from that, and you may have noticed I haven't talked about, in that many of the hyperconverged architectures do not include the network. That is good or bad, depending on how you want to look at it. Again, it's one of those wonderful, well, it depends answers, but it does have an impact when you want to set up your system, in that you may have to go into you will need to connect to your existing network, but you may need to make changes to your existing network. Whereas most of the converged infrastructures include the networking component, and they isolate that converged infrastructure from the rest of the network. So anything that they need to do in terms of QoS, multicast, changes to the network is isolated within that converged infrastructure. So now we come to the meat of it. Which one should you buy? And of course, you already know what the answer is going to be. It depends. It really depends on what you want to do with it. The nice thing about converged infrastructures is they're very, very flexible. You can adapt them, you can adjust them, depending on whether you want to, you can go the very rigid route with vBlock, you can go the much looser route with something like a FlexPod or a SmartStack. You can adjust them to match your needs. You can scale things independently. If your environment needs more compute and less storage, you can go for more blade servers or more rack servers and less storage. If your environment needs more storage but less compute, you can tweak it the way that you want it. Converged infrastructures can be used for almost any workload, and that includes bare metal. So if you have applications out there that won't or don't need to be virtualized, can't be virtualized, won't be supported if they're virtualized, you can run those in a converged infrastructure, whereas in a hyperconverged infrastructure, everything is going to be virtualized. Now, in most environments, that's not a particularly big deal, but it is something to be aware of. But of course, the trade-off between flexibility is always complexity, in that converged can be more complex because you can end up building this thing yourself, configuring it yourself, and while we've done a lot of work on the automation of that, no converged infrastructure is as clean and as simple as the hyperconverged infrastructures are. But the trade-off there is you get the flexibility back. With hyperconverged, they're simple. That's one of the real big selling points of any hyperconverged vendor, be it Cisco, Nutanix, SimpliVity, HP, Dell. Every vendor out there that's supplying a hyperconverged solution will tell you they're really, really simple and easy to set up. Typically, you're talking in terms of minutes or hours to set up the first time, and adding a new server is as simply as plugging it in. We do a lot of that on the converged side, but hyperconverged really takes it to the extreme. It's very, very easy to scale. So with hyperconvergence, when you're scaling, you're typically adding both compute and storage at the same time. So for something like VDI, which is a target market that hyperconvergence really works well for, then when you add a block in a hyperconverged architecture, you're automatically adding more compute and more IOPS at the same time. And with VDI, that's something you need to do because every VDI workload requires more storage capacity and also requires more storage IOPS, so that adding a chunk with both compute and storage IOPS in one hit every time really suits that kind of workload. So it scales very, very simply. Of course, the trade-off there is that if you don't want to add more storage, it can become a little bit more difficult to add a compute-only node to a hyperconverged environment. Now, lots of the vendors out there, Cisco included, now have the capability in their environments to add compute-only nodes to their hyperconverged solutions. But in some cases, that can make your life a little bit more complex because you then have to start thinking about workload placement. If your hyperconverged architecture really relies on localization of their workload, it's a bit more difficult to do. And as I said, with a hyperconverged architecture, you really are looking at 100% virtualized. So you can't really use it for bare metal workloads. And there are other workloads. Yes, you can run an Oracle backend database on like a hyperconverged architecture, but I know very, very few people who do it. I know any number of people who run an Oracle backend database using rack and all that kind of stuff on a converged architecture. It suits that big iron, big database type of environment a little bit better than a hyperconverged solution. Although, as I said, you can do it, it's just a little bit painful to make it work. So those are the trade-offs that you should be looking at. From a Cisco perspective, we are part of an enormous amount of converged infrastructure. I've already mentioned most of these, SmartStack, FlashStack, FlexPod, VBlock, vSpecs, VersaStack. We are part of pretty much any one of the converged infrastructures that are out there that are not single vendor only. Underlying it all is Cisco UCS, our automation tool, which simplifies the setup of the management of all of the aspects of a converged infrastructure, which is UCS Director, and then of course Cisco switching with Cisco Nexus. So we include the network as well. And then our friends from Eaton provide that fifth element that goes into a converged infrastructure, which is the underlying power infrastructure, where I was actually listening to a podcast this morning from the Packet Pushers team, where they were actually talking about, could you really think about moving away from a data center and back to a data closet? And the answer is yes. And between Cisco and Eaton, with something like a FlexPod and a 42U rack, and some of the stuff that Randy's going to talk about we can provide you an entire data center's worth of, what was 10 years ago, an entire data center's worth of compute and storage in a single rack with redundant power, with UPS and battery backup, and power distribution in that rack. So you can really start thinking about, can I move down to a data closet? And the answer is actually, yes, you can. And with something like a converged infrastructure and Eaton, we can do that together. Cisco's hyperconverged solution is Cisco HyperFlex. Naturally, being Cisco and a networking company, we included the network in our version, so we have complete hyperconvergence. We don't just include the rack servers, the storage software that runs on top of them, but we include the networking stuff on top of that as well. So you can treat it very much like a converged infrastructure, where all of the stuff that we need to do internal to the hyperconverged cluster around quality of service, any multicast, is all taken care of inside of the hyperconverged solution. So your upstream connection to your external network, you really don't have to treat that as anything other than that here's some network ports that provide the upstream trunks, or from your network's perspective, the downstream trunks. Data management, it's always on optimization and very flexible for scaling, and it's a future-ready architecture so that we can move it towards emerging applications. Where one of the things that we looked at was we didn't want to build this around a conventional file system. It's actually built around a log-structured file system. The advantage of log-structured file systems in the modern world is that they work very well with a flash architecture. where the way that a log structure file system works is you're always streaming data to the disk sequentially, so you're reducing the amount of random I/O, and because you're writing large sequential blocks, that happens to work with the way Flash wants to work very, very well. Plus, we've got built-in dedupe and compression that really adds no overhead because it's built into the underlying file system structure. So it's all done in line and without adding too much additional overhead. The HS data platform, it dynamically distributes data across all of the nodes simultaneously. So it leverages the cache in each one of the platforms, leverages SSD for fast writes, balanced space utilization, so no data migration required following a VM migration, because all of the data is automatically striped across all of the servers that are in the cluster. So even if a single server fails and VMs migrate off that server onto another server, there's no need to wait for the data to catch up because it's already distributed. Gives you very, very balanced space utilization, very, very clean architecture in terms of managing the data and managing your VMs. And then simplified scaling. From an application view, you have CPU, memory, SSDs, and HDs. You want to add more servers. We just extend the data across those servers, and that optimization will happen automatically. You can set it, it's one of the things when you add a server, it's one of the things that you can select. When will we actually do the data redistribution? Typically, you'd want to run that, sort of like 3 a.m. in the morning. You redo the data distribution, you get that new capacity, you get that new data, all of that capability from that server automatically. So it's very, very simple to add servers in. Equally, it's very, very simple to roll servers out. You just mark a server as no longer being part of the cluster. The system automatically rebalances the data. You then pull that server out and replace it. And as we move forward and you're going to start doing upgrades on a HyperFlex system, that makes upgrades very, very simple. You can do them as a rolling upgrade. And then we have independent scaling of compute and capacity, where if you want more compute nodes, but you don't need any more storage IOPS or storage capacity, you can just add some compute. So instead of having to add a node with storage and compute, you can actually just add compute-only nodes so that you simply extend the software, IOVisor software, which is part of the HyperFlex data platform. You extend that to those compute-only nodes, then they can access the resources of the storage in the rest of the cluster. So you can scale your compute independently of the actual storage nodes themselves. Lots of different configurations. We have small nodes, which are based on one new server, 3 to 8 node cluster. I forget the actual numbers on these, but note that we also include the network in here. We have capacity heavy, 3 to 8 node clusters. These come with up to 23 1.2 terabyte drives, and depending on whether you're doing two or three factor replication, depends on how much capacity you have available. And then we have this hybrid model where we can add compute-only nodes in a blade chassis to take advantage of the storage that's available on the storage-heavy nodes. So that's hyperconverged systems, and I'll just hand back now and let's start talking about how we want to implement hyperconverged systems in your environment.
Great, thanks. So guys, now that the audience has a nice, shiny new hyperconverged system on order, what do they need to plan for their server room or closet to make sure that when they start using it, it's going to be a success?
So I'll take the first section of that, and then I'll hand over to Randy, who I know has been chomping at the bit, waiting for me to shut up and stop talking, which is, I'm in product marketing. This is what I do for a living, I talk. So I'll try and get through this and let Randy talk to you a little bit about power. But the first thing for planning power is we'd always recommend go to the vendor's power calculator. So in our case, the Cisco Power Calculator, you can find at that URL there, fairly simple, ucspowercalc.cisco.com. You can then configure up the system, and it will give you an estimate of how much power it will use. Now, we always have to be very, very careful about what a power calculator is actually used for. It's for estimating how many servers you can fit on a circuit. So if you have a 20 amp 110 or a 30 amp 208 circuit, how many servers can you put on that circuit without worrying about the breaker popping or getting to the 80% limit on that circuit? Same thing on your cooling capacity. How much heat output will come out of these servers? So if I've got 10 kilowatts of, or however many BTUs, 12,000 BTUs, I think, of cooling capacity, how many servers can I fit in that cooling capacity? They are very, very much estimation tools. They're not competitive or comparison tools. There's real problems you can get yourself into if you try to take a power calculator from Dell, a power calculator from HP, and a power calculator from Cisco, configure up systems, and you'll get wildly varying estimates of power. And the reason for that is there's a huge difference in the way that we do our power calculators. But to start, the reason we do power calculators in the first place is we have these things called power supplies, and if you look on the power supply, that will say, this is a 750 watt power supply, its maximum input to get 750 watts out, because obviously it takes some power to run the power supply itself, is going to be 800 and something watts, and that will be your nameplate figure. Any facility guy or lady will tell you that input power to the power supply, you'll never even come close to it, because it's an engineering number, and engineers always over-design their power supplies. It's just, that's what you do. The last thing you want to do is have someone turn on their server, start running a workload on it, and then have it shut down because you can't get enough power out of the power supplies. We always oversize the power supplies. Nature of the beast. So the power calculator, what we can do as Cisco is give you two numbers. We can tell you what power it's going to use idle, and idle is a pretty well-defined term. It's basically when the system's booted up, an operating system, but doing nothing, with all the power management turned on. That's important, because if you turn it off, your idle number is going to be very different. And then we can give you a max power. Now, max power has a little bit of a looser definition, because there's no single benchmark that you can run that will give you the absolute max power. It's always a trade-off. If I pick one benchmark, it will give me one power. If I pick another benchmark, it will give me a different amount of power. And then your actual power utilization will be nothing to do with the calculator max power, unless you happen to be running the benchmark that we ran in order to get max power. So your actual power utilization is going to be all over the place, and that's that little blue line over here. Important things to realize, power varies massively with configuration. I've just run up two configurations through our power calculator here, and as you can see, it's blade chassis, single blade chassis. I just swapped out the 2680s for 2630Ls, a low power processor. I went from 16 DIMMs down to 8 DIMMs. I pulled the SSDs out and booted from SD cards. My power at max went from 4 kilowatts to 2.5 kilowatts. We give you this second number in the Cisco power calculator, which is a rough estimate of what a typical enterprise workload will use. This is a very rough estimate and also tends to be on the high side. That rough estimate for this system would be about 2.5 kilowatts, the one on the left, the one on the right, 1.7 kilowatts. Notice the idle numbers are very, very similar though. And that's because the processors and memory actually, when it's idle, all clocks down to its lowest power state. And really you're just looking at the difference between the SSDs not being there and 32 gig DIMMs not being there between 940 and 907. There's not a lot of difference. It's really at the high end where the power differences come in. And this chart is what I was talking about earlier with applications, where different applications, how highly threaded they are, will change the amount of power you actually consume. This was on a test system we were running some time ago. It was actually a competitor system we were actually testing with. I just happened to have this data knocking around. I'm not going to tell the competitor because it's not relevant. It's really about how much the power difference between this benchmark called Prime 95 running 2 threads and running 8 threads, it goes from about 4250 watts to 6,000 watts across this system. Spec JBB, which is another benchmark, was pulling about 5,000 watts. This was a customer application, a Monte Carlo simulation, which is the stuff they use for options and trading. And this was pulling just over 5,000 watts. And then this rendering solution, which was doing film compositing or image compositing for animations, was pulling about 4,000 watts. The important thing to realize here is every single one of these benchmarks pegged the CPUs at 100%. So my worst case was 6,000. My best case was 4,000 watts, but the CPUs were all running at 100%. And there is a huge difference, 2 kilowatts worth of power difference between 6 kilowatts and 4 kilowatts with the CPUs running at the same level, at 100%. So power really does vary with the application, and that becomes the problem of comparing power calculators, because Dell, HP, IBM, Cisco all use different applications to test for max power. So that means that really we're incomparable. You can't take the power calculator value from a Dell system and compare it to a Cisco system or an HP system, because we all run different applications to do this. There's going to be some changes around that over time. Energy Star from the EPA in their latest standard had started to create a standard through spec called CERT, and we're all starting to have to publish numbers, our CERT numbers, to get Energy Star, which, because it's a standardized benchmark, will make them fairly comparable. Again, but you're going to have to go and make sure that we're all comparing the same configurations, because if we're not exactly the same in configuration, there's a big difference between an E5 2699 and an E5 2630L in terms of power consumption. So that's something you need to look at. But I'll hand over now, and you can stop listening to me and start seeing what Randy has to say. So Randy.
Thank you, Tony. And I love the way that you really got started talking about the power in these environments. It really helps to drive the first point that I want to make, and it's that there are too many options. There are too many variables for there to be any kind of consistency. That's the reality. There isn't any consistency. And Eaton has realized that. And of course, us being a UPS, Eaton being a UPS manufacturer and vendor, our goal is to make it easy for partners to get the right power into these or whatever the environment happens. So before I really start drilling into all the different considerations that go into power configuration, I just want to make the world aware of a great resource, probably one of the best things that differentiates Eaton power environment, and that's our Eaton Care team. This is a team of about 15 engineers that sits in the beautiful Appalachian Mountains in Asheville, North Carolina. And the sole purpose of this team is to be an engineering resource, and anyone that's interested in buying an Eaton unit. It's not something that we bill for, charge for. It's a complimentary resource that we provide to potential. So there's an email address and an 800 number to reach that. What they're going to do is start asking you the questions that I'm going to go through as part of the next couple of slides. So they're going to help you take information about your environment and use that to get you closer to the right solution. So let me just jump to the slide. So right now, our kind of a top level or a high level approach to designing out a UPS, I'm going to break up the considerations into 3 broad categories, kind of an organize, protect, and manage approach. And so kind of to get it started, the organization piece is really a lot of upfront planning. It's looking at your power environment and seeing what's really available in your space. Do you have single-phase power or 3-phase power? At the end of the day, that's going to make a big difference in terms of what UPS you even can choose, or even further down the line, how much equipment you can put on those circuits. To Tony's point, there is a limit to the space, and that's all built around the power infrastructure. So that's where we're going to start looking, is what's available. The installation environment, that's really, are we talking about a clean white space or a dusty shop floor, or possibly even within an office space. So then you're looking at noise considerations. So all of those things play into what the final UPS can look like. And power distribution. Once you have brought the power into the space and then conditioned it, what are you going to do with it next? Is the UPS plugged directly into a server, so kind of a one-to-one scaling that works really well with hyperconvergence, not necessarily so much with CI, with converged infrastructure. In that case, now we're looking at possibly needing rack power distributions, and we have reference architectures that from most of the large converged infrastructure vendors in terms of what power distribution you should look at. Also, in our larger three-phase environments, you're going from the UPS to a panel board, so through circuit breakers and then to smaller circuits from there. And nobody really wants to have to be responsible for all of that. Again, that's where Eaton can come in and be the expert and make sure you're distributing the power in such a way that it's usable. And then when we start to actually look at the protection side, power capacity, how many watts are within the environments? That's where all of these different power calculators come into play. And to Tony's point again, every manufacturer, every server vendor is going to have a slightly different slant on their power calculator, so it's not apples to apples, and they don't stack well. So let Eaton come in and help you really take a look at your total load and get a good estimate. We have lots of data that we've collected over the years and kind of can mix and match those vendors however you need fit for your environment. From the scalability perspective, we see it time and time again. Customers will call in saying that they've outgrown their UPS, and since they didn't consider that up front, well, now they have a situation where they're either going to have to buy a new UPS to replace the old one or put in a second UPS beside it, in which case all they're doing is either driving up cost or driving down their reliability. So planning for those things up front can really go a long way. To the point of redundancy or reliability, that's where this availability piece is coming in, or total uptime. Eaton has a number of solutions that can increase the availability of the total system by increasing the reliability of a UPS. It's a machine, and machines do from time to time break down. That's nothing unique. But there are considerations you can take up front, such as using intrinsic N+1 redundancy in the power, so that for those likely to fail components, they're redundant. So the actual server loads don't see any downtime at all. And with management software, you can very quickly be alerted that there's a failure. Eaton service can come out and take care of that and make your data center whole again. But the whole time that's taking place, no server loads have gone down. Then when we get into the management category, or the managed category, we're looking at a couple of different things, and these are all going to be high level. So the software interface, do you need the UPS to talk to the network? Eaton has a really interesting software piece. It's called Intelligent Power Manager. That can do some really clever orchestration. That's not for all customers, but it's certainly something that we have that's available. Operation and maintenance, so we're looking at site training for the facility staff, maybe maintenance agreements with Eaton, possibly even, I guess the service contracts would be the main maintenance piece there, but some customers prefer to do their own maintenance, so we offer training for that as well. And all of these things, of course, have to fit within the final budget. So to kind of unpack a few of those things a little bit more, the electrical supply coming into the space, again, time and time again, my team in Avery Creek, we see customers calling in that just don't have the necessary utility coming into the space where they're trying to put this V-block or any other CI rack, or maybe they're trying to put together their own. They just don't have enough power coming in. So that's a good conversation to have up front. And Eaton can help make sure that you're asking the right questions and getting connected to the right contractor to bring that supply to the UPS. Once we actually get to the point of knowing what the UPS is, well, what are the final dimensions? Do you have enough space to put it in its final location? Another consideration that we just don't see customers taking, the path of ingress to where the UPS will be installed. Can the UPS actually fit? We had a customer once that actually had to remove a wall because nobody thought about a 90-degree turn in a narrow hallway that was leading into the utility space where the UPS was going to be installed. So looking at all of that up front is absolutely critical. Floor strength. We have several larger systems that exceed the standard second floor or above limitation of about 100 pounds per square foot. Lead is very heavy, and the predominant chemistry of UPSs today is a valve-regulated lead-acid battery. That must be taken into consideration. Slabs are great. Bottom floor, good place to put a larger system. Of course, when we start looking at these reference architectures and convergence and hyperconvergence, well, now we're looking at rack-level UPSs, and those don't bear nearly the weight. But a lot of those are also going on raised floors, which, again, have a weight limitation. It's just something that's necessary to think about. Ventilation, UPSs, today we're running upwards of 93+% efficiency, but that's still on a large enough system that 7% of inefficiency becomes heating for the room. And that you need to get that warm air out of the rack. So the rack can't be pressed up against the wall. The UPS probably can't be pressed up against the back wall. And there must be sufficient cooling into that space to account for it, because ultimately all white space hardware is 100% inefficient. Whatever goes into the data center becomes cooling. So that must be taken into consideration for ventilation and cooling. Wall receptacles that match the UPS plug. This is something that a lot of power vendors kind of take for granted in the market. They just assume that everyone that consumes a UPS knows all of the nomenclature for plugs and receptacles across the world. There's a wide variety of flavors. And, of course, no one's really expecting you to be that expert. That's where Eaton can come in and be that expert for you. We can make sure that what you have available is going to match what the UPS is going to come with, or we can make sure that we sell you a UPS that matches what you already have installed. When you start to get into larger systems, plugs and receptacles, at least from the UPS interface, is kind of irrelevant because you're looking at hardwired connections. In the U.S., 30 amp is the rough upper limit on what you can bring into a UPS through a plug. There are some considerations that will get you up to 60 amps, but we don't see a lot of that in the U.S. It's more of a Europe connector. So hardwired connections, well, there's considerations that must be made there as well, and that's almost always going to require an electrician. So it's good to think about up front. And we see this a lot. This question comes up often. Putting a small UPS at the point of use with a larger UPS in the back in a utility space somewhere that's powering the whole facility. And we see customers often coming in thinking that if they add a UPS at the point of use because it's closer to the equipment, that's going to increase the reliability. But the reality is that neither UPS is 100% reliable. So when you stack UPSs in series, you're actually driving your overall reliability down just a little bit. So there are some use cases for that, but it should be a one or the other situation. And then when using a UPS with a generator, a very common application is a UPS can only store so much energy for you in its batteries. So a lot of power outages are going to exceed the amount of time that you can actually store in a UPS. So a generator is a great thing to add in parallel to your to your utility, and then that's going to be transitioned back and forth through an automatic transfer switch at the facility level. And then the UPS would give you just the ride-through for that switching time, the time it takes the generator to spin up and start providing quality power, and then the transfer switch to actually engage that generator. That's a really great solution for protection against long power outages. But there are considerations. UPSs and generators, they work well together if they are planned to work well together. So if there's a generator already on site, that's something that my team needs to be aware of when we're having these conversations, because that's going to limit the amount of UPS that you can actually put on the generator and expect a good, clean solution. And, of course, all of this is going to have to fit within all of the local and state and federal electrical codes. So making sure that you have a quality contractor when you start these projects will make sure that you don't run into binds later in regards to coding problems. On the power management side, again, I referenced it briefly. Eaton has an application called Intelligent Power Manager, and it's a lot of things, but on the surface, it's an aggregation platform for all of your power nodes. That could be a UPS or a power distribution unit, and it doesn't necessarily have to be Eaton. We've made the software to pull in data from other vendors because we realize that Eaton doesn't dominate the power in these spaces. And there's existing hardware, there are preferences to other vendors, and that's fine. That's absolutely everyone's choice to make. Of course, we're going to have a tighter integration with our own hardware, but we make it possible to monitor a much larger range of products. And then, so after you've collected all of the data from this power equipment, the next level is to actually do something with that data. So what are we doing? Well, the easiest thing is going to be an orderly shutdown, but that's in most environments these days, 100% uptime is required. So we've taken our power management software and turned it more into an orchestration platform so that scheduled shutdown is really kind of the last resort if the power is down for too long and there's no other plan in place. So we can do clever things like trigger very specific migration of groups of VMs from one environment to another. We can power cap the Cisco UCS platforms through UCS Manager. So you could, since the UPS battery has limited chemical storage in its batteries, then to extend that, all you need to do is reduce the actual wattage. So the power capping functionality that Cisco offers is great for this, because rather than having to shut workloads down, we can just slow everything down a little bit, reduce the power supply demand on the UPS, and extend the runtime, giving you a better chance of riding through the event. In the US, the average power event is usually less than 10 minutes. So if you can cross that 10-minute threshold, usually you can greatly increase your chance of having to not shut anything down at all. And power capping makes that possible. And then remotely monitoring the UPS, that's going to reduce the maintenance complexity of the UPS, or as an owner of one of these systems, it keeps you from having to dispatch technicians to check on the UPSs periodically. Our software is going to bring in all the data from the UPS from the network card, so that from a single platform, from an office, you can see if there are any alerts, any battery failures that have come up, anything that would cause the data center to be at risk. All of that's going to bubble up into our software and allow you to make decisions somewhat proactively, particularly in the context of battery failures. We do test those in regular intervals, and we can usually get you a notification about 4 weeks before there's a true battery failure. So all of that remote monitoring ultimately makes it a little bit easier to maintain those systems. And then, of course, when there is a fault, the software is going to facilitate notification to technicians or anybody else that would be responsible for remediation of the system through emails or any kind of an SMS type of a notification. Now, when it comes time to actually start building out the white space, if you go with one of the converged infrastructure boxes, those are great because they show up ready to be installed. But that's a small piece of the market, so the rest of it must also be accounted for. So in terms of managing cables, this is very important. Rack hygiene is the phrase that we would usually use here. And it's important because airflow through the rack front to back is what's going to kind of be the differentiator between a successful deployment that doesn't overheat and one that has the tendency to overheat and cause failures. So a couple of design considerations to take in mind. Eaton has a great line of vertical power distribution units that run in the back of the rack. They're only about 1.5 inches, 2 inches deep, so they don't get in the way of your cooling fans. And then that's going to allow you to run power cords straight out of the back of the equipment and plug it in to a receptacle that's really close by, so you don't have to have long, cumbersome cables. To that point, the next point here, purchase short cables. Most IT equipment is going to come with 6 or 8 foot cables, and if you're building out your rack properly, you don't need cables that long. That's really designed to get you to something close by. But if you're making the investment to put a power distribution rack in the back, then you can use much shorter cables. 1 or 2 feet is usually plenty there. And then on the networking cable side, we have a line of lacing bars and or D-rings that's going to keep those cables pulled out of the way and looking neat, and not so much like a rat's nest, which, of course, the back of my lab. I have all of these things, but I make so many changes. Yeah, it's still to get a little out of hand at times. We all live in that world. And then when it comes to populating the rack itself, Eaton just came out with a new line of racks. We're calling them our Eaton RS racks, and they're completely toolless. Everything about it, the positioning of the rails, down to how the accessories are installed, it's all completely toolless. We've come out with a line of white and black. So the white's, of course, for high visibility, and the black's going to match the aesthetics of existing environments. And then when it comes time to start stacking equipment, put the UPS in the bottom, particularly if you're looking in the 5 to 11 kVA range. Those systems tend to be heavy, and keeping that UPS in the bottom of the rack is going to, of course, keep the CG as low as possible. And then another consideration, and I don't know if this is necessarily industry standard or not, this is my own personal preference, put the deeper devices in the bottom and the shallower devices in the top, so that as your warm air is coming out of the back of your IT equipment, it's going to have a tendency to want to rise, warm air, of course, being lighter than cool air. It's going to want to rise and come out of the back. So by tiering your equipment, you're leaving a larger void of air higher in the rack so that warm air, as it's rising, it has some place to go. And of course, Eaton has a line of racks that have a chimney top hat so that as that warm air is rising up and out, it has some place to go, and there's a channel through the back of the enclosure that air can flow through. It's going to greatly reduce the static air temperature in the rear of that enclosure. And then, of course, we already talked about the vertical PDUs in the rear and how those are going to help to keep your cabling out of the way so that you don't have to worry so much about airflow getting dampened by your cabling. And then blanking panels in the front of the rack. If you are doing proper rack hygiene, even if it's not necessarily an enclosed cold aisle or an enclosed hot aisle, it's still a good idea to have blanking panels covering up the unused U space so that you don't have recirculating warm air coming back to the front of your rack to go back through the intake and then get warmed up even further. And I had alluded in the beginning to kind of some reference architectures that Eaton has. And so here's an example of a reference architecture that Eaton has with the Cisco HyperFlex system. So this is something that Eaton and Cisco have validated together. This is a known configuration with the HyperFlex on top and then the Eaton solution on bottom. And this is something that we know is going to work. It's going to provide sufficient power so that you don't have to think about all of those unknowns that we've mentioned before. You don't have to worry so much about which PDU is going to be the correct distribution or which UPS is going to provide the correct power quality for such a rack. Eaton and Cisco has taken all of that into consideration and put this reference architecture in place for you. And I don't know, Tony, did you want to speak anything to this slide?
No, I think you got it covered really well, Randy. We put a joint white paper out covering how to power up these compute-intensive HyperFlex systems, and again, it gives you that architecture that says, you can this PDU, this UPS, and then you don't have to worry about it.
All right. Well, thanks, Tony. And then with that, I think we are back to Spiceworks.
Great, guys. Thanks for all that information. But what are some considerations for implementing a converged blade solution?
So once again, power calculator. You'll get bored with us talking about power calculators, but it's really important for this kind of stuff. You need to be able to estimate what kind of power you're going to use. So I'm not going to redo the entire talk about power calculators, but you really need to refer back to the power calculator to get the idea of what that blade chassis is actually going to use in terms of power consumption. And then plugs and receptacles. Always an interesting subject, Randy. Where should I put this plug?
Yep, and nomenclature. I touched on this a little bit. Eaton, particularly as a power vendor, we assume that the whole world knows naming nomenclature. We assume that everybody knows that a 515 and an L530 are not the same thing, and that's just simply not true. So just as a quick overview, since we're all talking about it, 515s. It's going to limit you to about 1,500 VA. Really, it's about 1,400 watts, which is really what we talk about in the white space is wattage. Nobody cares about volt amps. And that's assuming that it's 120 volts. That NEMA 5 designates that this can only be energized to 120 volts. So to the question, a converged blade, really the biggest consideration there is density. And in most cases, a 515 or even a 520 is probably going to come up a little bit short of what this blade is actually going to need. So now we're jumping up into the 30 amp, and that's where we're getting up to about the 3,000 watt mark. And of course, that L in there is going to designate the locking plugs, and that's a great thing whenever you don't want your equipment to accidentally get unplugged. So, and then to take it just a little bit further, here's the larger gamut of receptacles, and this still is not inclusive. But now we're starting to get out of the realm of just the 120 volt and more into what we can do with 208 volt, which again is going to play back into that density. Ohm's law is going to tell us that if I can increase the voltage, I can decrease current needed. And when it comes to conductor sizing, ultimately what's going to dictate the limit of that circuit is the diameter of the copper that the electrician ran from the breaker to the receptacle. So if we can increase the voltage on that circuit, then we can decrease the demand for current and get the customer the wattage that they actually needed. And so this slide here is probably a better representation of what we're going to see in a blade type of a converged blade type of a scenario. These are going to be much higher density receptacles.
Yeah, and typically, just to jump in here, you'll find that most blade architectures will have a C19, C20 combination on the rear. So we would expect, in the Cisco UCS environment, for example, we have 4 C20s on the back. So we expect to use a C19, C20 jumper cable to go to the PDU. Similarly, HP have 6 C20s, if I remember correctly, and I think the Dell chassis also has 6 C20s. So for most blade architectures, you'll be looking at that C19, C20 jumper to go off to the PDU, which of course then, Randy, will affect which PDU you need, because you're starting to need more C19s on your PDUs then.
Absolutely, and since those C19s, they're unique in that they require a 20 amp breaker to protect them rather than the standard 15 amp breaker. So from a PDU design consideration, when we're building those high density PDUs, if we've got a PDU that's going to need 6 C19s, that's now 6 20 amp circuit breakers, that's going to impact the cord that we Eaton have to put on it. So now we're starting to look at really needing to bring possibly 3-phase power into that environment, just to provide enough energy or enough wattage to the PDU, ultimately to those power supplies. So again, I know I already drove the point, but my team in Asheville, that Eaton Care team, they are the experts on these plugs and receptacles, and they can take whatever the workload requirements are and work that backwards through a full distribution and turn all of these letters, numbers, and dashes into something that can actually be installed and work. And from a UPS design consideration, I mean, the same consideration for plugs and receptacle types must be taken. And we have a couple of different approaches to the flexibility of receptacles. Really, under 3 kVA, the UPS is going to have the receptacles that it comes with. That's across the market. That's not Eaton specific. But as we start to get into these higher density solutions, we're running into larger UPSs, and our larger UPSs have larger flexibility for customization. So we can really start to put the outlets that are needed on the UPS so that you don't have to necessarily bring in an electrician to run custom circuits to the rack. You would just bring the necessary power to the UPS, customize the outlets on the UPS, and then run your PDUs straight over from the rack into the UPS and reduce the overall installation cost. And I think that's going to wrap it up for me.
All right, guys. Thanks for that awesome presentation. Now let's get into some questions. Our first question is from Brian. What sets Cisco HyperFlex apart from other vendors such as Scale?
So again, one of the big things that sets Cisco HyperFlex apart is the fact that we included the networking in the solution. That can make a big difference to a lot of customers because, for example, some of the vendors out there, the hyperconverged vendors out there, require that you set up multicast on your network, which means that you then, when you bring in your hyperconverged solution, now, if you're the network manager, SAN manager, server manager, and it's all you, then obviously that's a little bit more easy. But if you have a network team, then you're going to have to make sure that you plan with your network team that they will set up that multicast environment for you before you bring in your hyperconverged solution, because if you don't, it's going to delay the configuration. With HyperFlex, What we do is all of that stuff is included under the fabric interconnects. So all of the QoS, any of the networking stuff that's specific to that hyperconverged cluster is all set up and hidden from the external network. So all that the networking team need to provide is a couple of trunks and the appropriate VLANs, which they would have to do for anything anyway. And it's very, very simple and very, very easy. So that's one of the big differentiating factors between us and most of the other hyperconverged players.
All right. Michael wants to know, is it possible to use HyperFlex as a target for Hyper-V replica for DR?
At the moment, not for Hyper-V. At the moment, HyperFlex is very much focused towards VMware. That's something that we do have on the roadmap for a future release.
All right. Anthony wants to know, how well would a hyperconverged system support an Exchange and a SQL installation?
Whoa, we'll need to get back to you on that one because I need to go and talk to one of our technical marketing engineers.
All right, so Anthony, somebody will follow up with you. Charles asks, for powering the data center with Eaton, what are good UPS systems for network switches and then servers that are network-connected devices to be managed from a central location, specifically with software that can enable clean shutdown and auto power on?
All right, so I'm going to borrow an answer from Tony on that one. It depends. So my generic answer for what UPS should I put on a network switch is probably going to be the Eaton 5P or the Eaton 5PX. The biggest difference there, the X is going to add the ability to put external batteries on that system. Now, the reason I say the 5P and not something else, Eaton we break up our UPS product portfolio into 3 categories, and that's based on the level of protection that the UPS can provide. So there's a 3 series, a 5 series, and a 9 series, and I'm not going to go into all of that right now, but the 5 is kind of the middle of the road, and network switches are, the power supplies in the switches are resilient enough to make it really difficult for me to try to convince you to buy a premium UPS when a middle-of-the-road UPS is going to do the job just as well. So the short answer there, 5P, 5PX, and I would absolutely recommend a network card in either one of those so that you can bring that back to the Intelligent Power Manager platform for monitoring. Now, on the server side, the answer is still pretty similar. The 5P, 5PX, it's going to work. It's still going to power that system well enough. You're looking at about a 4 millisecond transition time from the UPS losing its input power until the batteries can start providing output power. Most IT equipment can get through that 4 milliseconds without even knowing that anything has happened. If there's ever any concern, if it's a really high-end server that has a tendency to put out more harmonics than an average server would, that's when we would start to really push you up toward our 9130 product line, or bigger depending on the size of the server, maybe even a 9PX, which is going to get you up to the 5 or 6 kVA mark. And regardless of which UPS you pick within that gamut, and again, the Eaton Care team can help you really make the right decision there, regardless of which UPS you pick, and assuming that there's a network card installed, Intelligent Power Manager is going to allow you to map through the GUI. You create a linkage between the UPS that's powering the server, and then you would create, again, through the GUI, a script that dictates what that server is supposed to do after a certain amount of time on battery. So be it shutdown or live migration, or maybe you're using Site Recovery Manager. That's another thing that we can do as part of a disaster avoidance. But IPM is then going to be responsible for sending that shutdown command to the server in response to the UPS, and all that's configured as a policy definition combined with an action definition within our platform. And
yeah, I'd just like to add a couple of things to that. One, simple one, that 4 millisecond swap over time, all of the Cisco UCS power supplies are more than able to hold up for longer than that. In fact, the spec is 12 milliseconds at full load. So that's well within our spec. Then the other thing to think about with when you're powering network switches is if you're using voice over IP phones and if you're using power over Ethernet for those voice over IP phones. Because that can add in some additional considerations to UPS runtime that you really need to think about, especially if you expect people to be able to continue to work and use a phone or even make potentially emergency calls. If everything's going to be voice over IP and power over Ethernet powered, you really need to start looking at extended run times at that point. You don't want to be holding up those phones for just 5 minutes. You want to start thinking about how many hours can I hold up those phones.
That's a great point, Tony. That's a great point. And then,
all right, guys. So it is time for us to wrap this up. Do y'all have any final words for our audience?
Nope, it's been great. I hope we gave you some useful information, and we really do value your feedback. So let us know how we did, and we'll be running the second one of this, and we'd like to take some of your questions, get your feedback, and roll it into the second one of these.
All right, fantastic. I do want to remind everyone that if your question wasn't addressed or if we didn't have all of the information, somebody will be able to follow up with you. Also, if you had to step out or miss any part of this presentation, you'll be getting an email with a link to view the webinar on demand in just a few days. As I mentioned earlier, this is part 1 of a 2-part series, so be on the lookout for a link to sign up for part 2 in just a few days. Want to say special thanks to Cisco and Eaton for creating today's content and sponsoring this event. And thanks to each and every one of you for tuning in today. We hope to see you back soon for another SpiceWorks Partner webinar. Until then, stay safe and keep it spicy.